Hey guys, Assalamu alaikum. This is a session for kinetic particle theory and measurement of different things, different measurements in the lab, and introduction to lab apparatus. This session is related to some past paper questions. Here, right now, in front of you is kinetic particle theory and lab apparatus questions are there. Two MCQs are there. So we can talk on these two questions. Okay, so a student investigates the rate of reaction between calcium carbonate and hydrochloric acid. We can see this thing that a conical flask is there. Hydrochloric acid is reacting with calcium carbonate. We can have a look that here is some bubbling production over there. Bubbles are representative of a gas production. Whenever in a chemical reaction, bubbles are shown over there, so these bubbles can tell you that gas is producing. There are certain reactions in which a gas can be produced. I am telling you that whenever a metal carbonate is reacting with an acid, carbon dioxide gas is produced, and whenever a metal is reacting with any acid, hydrogen gas is produced. So these are the two common ones which I have told you. With the passage of time, certain chemical reactions will be discussed with you in which gases are producing. But this bubble production is an indication that a gas is produced in this chemical reaction. Okay, let's read the question. The volume of gas in the syringe is recorded after 1 minute. The experiment is repeated using different concentrations of hydrochloric acid. Which additional piece of apparatus are essential for this investigation? Okay, the answer is B. Why answer is B? Let's have a look. It's balance and measuring cylinder stop clock. Okay. They are telling you here the experiment is repeated using different concentration. Okay. They are saying you that syringe is already there, and for the different concentration you have already this measuring cylinder. So what we can use in this balance, because they have not mentioned about the mass of the calcium carbonate, and the stop clocks. Why stop clock is required? For different interval of time we have to measure that this much gas is produced in this much interval of time. How we can know this thing that this much amount of a gas is produced, this much volume of a gas is produced? This is gas syringe. Here there are numbers over there which are telling you that this much volume of a gas is producing in this case. So it is the balance which is used for the measurement of calcium carbonate, whereas this is the gas syringe which is used for the measurement of the volume. As gas syringe is already given, so there is no point for requirement of the gas syringe. And as they are mentioning about the different concentrations already, it means that we are not required for the measuring cylinder. Some of the students might get confused about different concentration word. It means that different amounts of acids are taken one time, like let's say 10 centimeter cube of HCl and 90 centimeter cube of water. Second time 20 centimeter cube of HCl and 80 centimeter cube of water. Third time 30 centimeter cube of HCl and 70 centimeter cube of water. So in this way, we have taken variable concentrations of HCl in this case. So here they are mentioning different concentrations of HCl. It means that we are not requiring measuring cylinder. Sorry, so it's the balance and the stop clock which we are going to use. B option is the right option. Okay, let's have a look on the question number 2. Which statement is correct? This statement is related to this question is related to lab, you may say some practical type of thing, or you may say some measurement type of thing. We have discussed this thing in the class that there are different types of the lab measurements. One of them is using the temperature measurement, mass measurement, and you may say that time measurement, and we can implement this to measure the purity of the substance. There are three purity checking techniques I have discussed with you in the previous lectures, and I have uploaded them on the YouTube as well. And there were measurement for the temperature regarding the melting point determination to check the purity of the solid, that is boiling point determination for the purity checking of liquids, and then paper chromatography. So here let's read the statements now. Mixture of liquids with boiling points which differ by 35 degrees centigrade can be separated by distillation. Okay, so locating agents are needed to identify the colors present in ink. We cannot use the locating agent for this purpose because the points of the ink on the paper chromatography will be colored, or obviously, so there is no need of locating agent. The desalination of sea water to produce pure water is achieved by fractional distillation. No, in fractional distillation, basically we are using the liquids which are 100% miscible into each other. They are 100% dissolved into each other, and they have a very low difference of their boiling points. Fractional distillation is basically used for that. If we are talking about this desalination thingy regarding conversion of the seawater into drinking water, we can use the technique of simple distillation, not the fractional distillation. So C is wrong. The RF value of dye in a chromatogram can be calculated by distance traveled by the solvent divided by distance moved by the spot. We already know this thing, that this is a wrong formula. What is the formula of RF? So it is RF is called as a retention factor. We are implementing this RF thing in paper chromatography. And what is the RF formula? RF is equal to distance moved by spot divided by distance moved by solvent. So RF, this D is wrong option. I'm marking over here. This D is a wrong option. The desalination thing is wrong option as well. And locating agent are needed to identify the colors present in ink is wrong as well, because ink spots are already colored, so it is not requiring some additional locating agent. Locating agent is a substance which we have used in the paper chromatography to shift colorless spots into color spots. So it is A option. A mixture of liquids with boiling points which differ by 35 degrees centigrade can be separated by distillation. Okay, so this can be used. Basically, this is the correct statement. All right. Now I am taking you to another question. Okay, let's have a look on another question. Just give me a few moments to find another question for the kinetic particle theory. All right, guys, this question can be asked from you. Let's see the A part of question number one only. I'm not talking about the rest. For example, what is the name of A? It is called burette. What is the name of B? It is called pipette. And C is conical flask. Okay, I am on another question now. Okay, and here we can find out some questions related to kinetic particle theory. All right. Yes, look at question number one. Stearic acid has a melting point of 69 degrees Celsius. A heated sample of pure stearic acid is cooled, and the temperature is recorded every minute for 30 minutes. A graph of the results is shown. All right. Which process occurs between 8 to 12 minutes? Okay. 8 to 12 minutes. It means that examiner is talking about this. Okay. 8 to 12 minutes. Okay, whereas its melting point is 69. Okay, so it means that it is not going to melt at this, it is not going to happen over there. So which process occurs from 8 to 12? Okay, we can see this thing, the temperature is going down, so it is called melting. Basically melting at 69 degree Celsius is this, and this is the temperature of 70, so it's nearly 60 69, I guess. So if we are looking at this very carefully, so this is the melting. D is the right option which is happening over here. Which statement are correct? Which statements are correct? The volume of a gas at constant pressure increases as the temperature increases. Okay, let's discuss this. If we are talking about question number two, guys, this is somehow related with Boyle's law and Charles' law. I am writing the names of these laws over there, Boyle's law and Charles' law. What is Boyle's law, guys? It is the law which is related to pressure is inversely proportional to volume. So if temperature is kept constant and if pressure will be increased, volume will decrease. If pressure will be decreased, volume will increase. Pressure and volume are inversely proportional to each other when we are talking regarding Boyle's law. But in the study of the Boyle's law, one has to keep temperature constant. If we are talking about the Charles law, temperature is directly proportional to volume. If we will increase the temperature, kinetic energy of the particles will increase. Particles will hit each other more frequently. They will occupy the area available. As a result, we can say that by increasing the temperature, volume will increase. By decreasing the temperature, volume will decrease. Okay, let's read the statements now. The volume of a gas at a constant pressure increases as temperature increases. Yes, this is correct according to Charles' law. Now the statement number two, when the pressure of a gas is increased, the particles move closer together. Yes, when we will increase the pressure, obviously the particles will come closer together. So two is correct as well. Okay, let's read number three. The pressure of a gas at a constant volume decreases as the temperature is increases. No, we cannot say like that. Pressure and temperature. Okay, let's write down that pressure. Okay, 1 over V, okay, and temperature is equal to, temperature is directly proportional to volume, okay. Guys, so what it will be, pressure, and it is like this, PV is equal to nRT. Guys, this is equation which is called, this is an equation which is called as general gas equation. I am really very sorry, I must say this thing. This is the equation which we will teach you in AS chemistry. But right now I'm just saying you PV is equal to nRT is just telling you the pressure of a gas at a constant volume decreases as the temperature increase. No, why it is so? Because we can see from this equation that pressure and temperature are in the direct relationship with each other. So we can say this thing that if we are talking about, this relationship, pressure of a gas at a constant volume will decrease when temperature will increase. It will not happen when we will increase the temperature. Particles are hitting each other more frequently. As a result of that, their volume, the pressure will be increased as well. So pressure will not decrease, rather by increasing the temperature, pressure will increase too. So option number 1 and 2 are the correct option. Guys, there is no need to keep this equation PV is equal to nRT right now in your mind. I have just told you about Boyles law and Charles law. You people should keep Boyles law and Charles law in your minds to solve some of the general questions, some of the common sense questions here in chemistry. Okay, now we are talking about question number 3. Which substance would diffuse most quickly? We have studied diffusion. What is diffusion? Diffusion is the movement of particles from an area of higher concentration to an area of lower concentration. So diffusion is affected by two of the factors. I have told you in the class, and the YouTube lecture is uploaded as well. We can say this thing that diffusion is based upon two factors. One of the factor is temperature, whereas the other factor is molecular mass. Okay. Higher is the temperature, higher will be the diffusion. Lower is the molecular mass, higher is the diffusion. So diffusion is directly proportional to temperature, but it is inversely proportional to molecular mass. Okay. So we can say this thing that it is carbon dioxide at 0 degree centigrade or neon at 25 degree centigrade. Yes, it is neon at 25 degree centigrade. Why it is so? Let's write the formula of carbon dioxide. It is CO2. What is the molecular mass of carbon dioxide from the periodic table? Carbon's atomic mass is, relative atomic mass is 12, and oxygen's relative atomic mass is 16. As there are two oxygens, so we have to write, we have to write 16 for 2 times. The total molecular mass, the relative molecular mass of carbon dioxide is 44, whereas neon's mass is 20. Okay, so neon's mass is much lesser as compared to carbon dioxide. So it is really very easy to diffuse this. We can say that it will diffuse with a greater speed, and 25 degrees Celsius is a greater temperature as compared to 0 degrees Celsius. So D is the right option. Let me find out some more questions for you so that you people may be able to practice some past paper questions perfectly. Okay, I am going to share one more question. Okay, let's have a look on this question. Okay, a sample of rock salt contains sodium chloride and sand. Okay, sodium chloride is soluble in water, sand is insoluble in water. This is basically not related to kinetic particle theory. This is not related to gas collection as well. This is basically part of the chapter purification and separation techniques. Okay, so it is basically separation, but let me handle some apprentices here. Okay, a student, sodium chloride is soluble in water and sand is insoluble in water. Sometimes, sometimes examiner is not telling the solubility of the substances as well. Students should have a common sense to know this thing that sodium chloride is soluble in water. I will tell you about the solubility of certain substances as well. There are some general rules to identify the solubility of the substances, but sand is insoluble is really very common sense. Okay. So sodium chloride is soluble in water and sand is insoluble in water. A student obtained dry crystals of pure sodium chloride from a lump of rock salt. Rock salt contains sand and sodium chloride both. Okay, rock salt contains rock and sodium chloride. Okay, there are some of the steps the students use. In step number 1, rock salt is there and pestle and mortar are there. Okay, guys, which one is pestle and which one is mortar? You can find out this thing right now. Okay, so this is pestle. I'm telling you, this is pestle. Okay, and this is called mortar. Okay, this is mortar. Okay, Now, in name the apparatus in step A. So here you have to write mortar, okay, not pestle and mortar, only mortar. Explain why the mixture is heated and stirred in step number 2 so that sodium chloride may get dissolved properly. Okay, name the apparatus labeled B. What is apparatus labeled B? It is called as the filter funnel. Some of the students will write funnel. It is better to write filter funnel. Okay. State the scientific term of the sand left on the filter paper in step number 3. It is called residue. It is called residue here. Okay. And then describe what student must do after step number 3 to obtain the dry crystals of pure sodium chloride. Student will shift a solution of sodium chloride from this conical flask to china dish. Guys, we have discussed about china dish. It is an apparatus like this. Student will shift what the solution from a conical flask to china dish. Student will keep this china dish on a bunsen burner on a tripod stand, and then will heat it to saturation, till the saturation point. What is the saturation point? When water content is removed to a higher level, and we can say this thing that lots of water is removed, and very smaller amount of water is left, then we can shift the saturated solution and we can left it cool. We can switch off the burner, and then we can left that saturated solution in china dish at the side of the lab, and we can left it to cool. As a result, what will happen? Water will be evaporated 100%, and 100% pure crystals of sodium chloride will be left. Okay, let me find out another question for you, so that you people may have an idea that examiner can ask about the apparatus directly, about the processes, about the names of different diffusion processes, and etc. Okay, here is a question. Let me find out that question for you. Okay, guys, there is another question. Yes, we can look at question number 4. It's related to balloon thingy. So, which diagram show the arrangement of the particles inside a balloon containing a mixture of the gases nitrogen and oxygen? Okay, nitrogen and oxygen. Guys, nitrogen is formula N2. Let me tell it to you very clearly. Nitrogen formula N2 and oxygen formula O2. It cannot be D. We can see one nitrogen and oxygen atoms are combined together. So it is not N2 and O2. It is C option basically. Why it is so? Because it is not possible for N2 and O2 that they are making layers in balloons. Okay, so N2 is the formula for nitrogen and O2 is the formula for oxygen. So it is C, where both of them are randomly mixed up with each other. Okay, question number 5, 6 and 7 are currently not part of your syllabus. I will solve such type of many questions once let me finish these chapters with you. Okay, and then I am telling you the questions related to kinetic particle theory and lab apparatus. Okay, some of the questions we have solved. Let me figure out some more questions. Okay, this is the question. All right, great. So we can look at the question number 1, a gas which is less dense than air and dissolves in water. So it means that it cannot be collected through water because it's soluble in water. A gas which is soluble in water cannot be collected through water. So which diagram shows the correct method of collection of the gas? As it is less denser, guys, it is written less denser. Okay, whereas it is written very clearly that it is soluble in water. Okay, it is soluble in water, so it cannot be collected through water. Okay, so this is the wrong option. This method cannot be used because it is less denser, so it will come out of it. It cannot go down because it is less denser, so B is the right option for this. Okay, so now the second question is not related to the lab process, rather it is related to separation and purification. Somehow they are asking that which mixture can be separated into components by adding water, stirring and filtering. Okay, so it is basically calcium carbonate and sodium chloride. It is A option. And why? For this question, you people should know the solubility. I will teach you about solubility. Right now, I'm just telling you before time that calcium carbonate is insoluble in water. Calcium carbonate is the name of marble stone. So it is just an evidence that we are washing our floors in our home and nothing is happening. So it means that calcium carbonate is insoluble in water, whereas sodium chloride is our table salt, which is soluble in water. So we will take this mixture of calcium carbonate and sodium chloride. We will add it into water. Sodium chloride will dissolve in water, whereas calcium carbonate will settle down, and the whole mixture will pass through filter paper. Sodium chloride will trickle down, whereas calcium carbonate will still on the filter paper as a residue. Solution of sodium chloride can be evaporated till saturation, just like the previous detail I have just told you in a question, and then it can be obtained through saturation process. Okay, I am just telling you one more question, one or two more questions, so that you people may have a good idea about how to solve the questions related to these two chapters, kinetic particle theory and lab apparatus. Guys, you can see this thing that there are some other questions in which examiner is asking about the different types of the apparatuses. Okay, that's really, really important. Okay, let's have a look on this question. A student has to measure 28, exactly they have mentioned 28.2 centimeter cube. Beaker cannot be used. Okay, guys, whenever they are telling you 25 centimeter cube exactly, then you people have to move towards the C option, and that is called as a pipette. Pipette is exactly measuring 25 centimeter cube always. And then they are asking 28.2. Whenever there is a figure like 28.2, 16.3, 12.7, etc., in those cases student has to select the burette. Burette is an apparatus about which I have given you an idea that it is an apparatus which is used in titration reaction. We have discussed this thing in detail in class already, but I am telling you that whenever figures like 47.1 and 29.3, such type of values to be measured, it is accurately measured by an apparatus which is called burette. Okay, so B is the right option. Let's look at question number 2. Which property of liquid ester can be used to check the purity before use as a flavoring, food flavoring? Okay. Guys, you people are unaware of many terms right now. For example, you are unaware of the term ester right now. For example, it's used as a food flavoring right now. I will teach you the topic of organic chemistry, inshallah. Over there, we will discuss about ester and its uses. So you may keep this thing right now in your mind that you are using vanilla essence in many types of the sweet dishes. But right now, we can say this thing that ester is a substance. Ester is an organic compound which I will teach you in organic chemistry, inshallah, and that is used for flavoring agents. Okay, that is used for flavoring of the foods, for cosmetics industry, for different types of the solvents. I mean to say, to dissolve certain substances, and it is used in the perfume industry as well. So these are the general uses of the esters, which I have just told you before time. But right now, our concern is to check the purity. Guys, I have told you that there are 3 purity checking techniques part of your syllabus. Number 1 is melting point determination, boiling point determination, and paper chromatography. So it is A option, which is boiling point right now. Okay, you can keep that in your mind. I would like to solve few more questions with you to give you much more better idea about these two chapters. Okay, great. I found another question. Which set of changes to the conditions increase the volume of the gas? Okay, by increase in the volume of the gas, I mean to say, I have just discussed Boyle's law and Charles' law with you, and here I can tell you that by increasing the temperature and by lowering down the pressure, volume of the gas can be increased. I'm writing here, pressure is inversely proportional to volume regarding Boyle's law, whereas temperature is directly proportional to volume according to Charles' law. So we can say by decreasing the volume, so it is A, and by increasing the temperature, it is A option, which will be selected for the increase in the volume. We can say right now very clearly that we can increase the volume by decreasing the pressure, and we can increase the volume by increasing the temperature. There is another question as well. Question number 5, guys, we have solved such type of many tube questions in the class as well regarding diffusion. Ethyl amine gas and hydrogen chloride gas react together to form a white solid, ethyl amine hydrochloride. Okay. At which position in the tube would a ring of solid white ethyl amine hydrochloride form? Okay, let's write down their formula. Luckily, their formulas are given. Hydrochloric acid formula is expected to be in your memory, but formula like ethyl amine is not expected to be part of your memory right now at this stage of O levels and IGCSE. It will be taught to you in AS chemistry. Right now, I'm telling you that ethyl amine is there, periodic table will be there. I have written already that what is the molecular mass, relative molecular mass of ethyl amine from the periodic table. We can see carbon is 2 times, so it is 12 plus 12, hydrogen is 5, and so if one hydrogen is 1, 5 hydrogens will be 5, nitrogen is 1 time, so it will be 14 as it is, and hydrogen is 2 times here, so 1 plus 1 is 2 here. It is 45 in total. When we are talking about hydrochloric acid, it is 36.5. And how it is 36.5? One hydrogen is 1, whereas one chlorine is 35.5. So the total will be 36.5. Okay, we can say this thing that this you may say that it will be formed at point B. It is in the center basically. Okay, so it is this distance will be traveled by what? This distance will be traveled by HCl, whereas this distance will be traveled by what? This distance will be traveled by ethylamine, and it is somehow in the center of the tube because their masses are not that much different from each other. Guys, I have solved one more question with you in which we have discussed this thing that one side was containing 36.5, that was HCl, and the other side was containing ammonia, that is 17. Over that, we have said this thing that that white color cloud of ammonium chloride was forming at point C, which was more towards HCl, because you should know this thing that a heavier gas will travel the smaller distance, whereas the lighter gas will travel larger distance. Here, both of the gases, both of the things have comparatively closer masses with each other, not a very huge difference, not a very big difference. So we can say that they are forming at point B. Okay, so they are more or less it is in the center of the two. Okay, so I am solving another question with you, and you people can send me some of the questions if you want, as in as a part of the comments in the YouTube as well, and you can send me on my WhatsApp number as well. All right, so this is right now I can find out some of the more questions related to kinetic particle theory. Right, not here. I will solve such type of many questions with you once you people will be able to solve some of the content list with me already. Such type of questions can be asked from you as well, but right now none of the question has been done with you. Is purple in color can be asked only. I have discussed with you that which substance in purple in color. Guys, we have discussed in the class that KMNO4 is purple in color. So this is the answer for that question. Right now, only this is the part of question which you already know. Rest of the questions cannot be asked from you at this stage as far as the concern is related to kinetic particle theory and lab processes. I guess, guys, many of the questions have been solved related to kinetic particle theory and lab process, and these questions are sufficient to tell you, to give you an idea that what type of practice you people should make. I have solved some of the questions related to ATP. I have solved some of the questions related to MCQ, and you people can find out that same will be implemented in the theory questions. I will try to upload another lecture related to theory questions as well. Thank you very much. Take care. Maybe